All right, so we are now moving into our last unit of Algebra 1. So Algebra 1 has 10 units, and we have now made it to Unit 10. So what this lesson is about, what this whole unit is about, is something called exponential functions. So exponential functions have a lot of real-life application to it. So in the next couple of weeks, we'll talk a lot about how you would see it in the real world. But we're first going to start with a little situation to help you understand what an exponential function is. So this first piece is not in your packet. This is just something for you to watch and understand, and then we'll go into your packet with the Unit 10 notes. So what I'm going to ask you is, would you rather me give you $1 million, or would you rather me give you a penny, 0.01 cents, that is going to double every day for 1 year? So I want you to think about that. Would you rather have $1 million, so I'll just hand you $1 million, or would you rather have a penny where the value of that penny doubles every day for an entire year? Okay, so let's take a look at this. So if you decided that you want the $1 million, we would just give you the cash and you would get the $1 million. But if you decided to go with the penny, what happens on the first day is that you have 0.01 cents. On the next day, it's going to double, so we're going to multiply it times 2, which is 0.02. And then it keeps doubling, and it keeps doubling, and it keeps doubling. So soon you will have, let's say it's $1. $1 is going to double, and that becomes $2. $2 is going to double, that becomes $4. $4 doubles, that's 8. 8 doubles is 16. 16 doubles is 32. 32 double is 64. 64 double is 128. That doubled is 256, and so on. So if you ended up choosing the double option, over the course of 365 days, that penny would turn into over $4 million. Okay? So the power of doubling is that this number started off really small, but then it got bigger and bigger and bigger and bigger and bigger. Every time, times 2 times 2 times 2, it gets really big really fast. So that's what we're going to talk about in this unit, is we're going to start with a number, and we're going to have a multiplier, and that number will get bigger and bigger and bigger, or it could get smaller and smaller and smaller. Okay, so this is called exponential. Exponential means that a number gets really big or really small really quickly. Okay, so let's go into our packet and let us find Unit 10. So your Unit 10 notes look like this. Excuse the fact that my handwriting is not the best today, but we'll make it work. Okay, an exponential function. So this year you've learned 2 different types of graphs. Y equals mx plus b. That type of graphs a straight line that has a slope and a y-intercept. Then in this last chapter, you graphed x squared plus x plus a constant. You can also put an a, b, c there. So what you have there is called a quadratic function. So quadratic functions is the unit we finished right before your practice start. It makes a U shape. And then a linear function makes a straight line. So those are the 2 different graphs that we've learned so far in Algebra 1. You can graph a straight line, or you can graph a U shape. So today we're going to learn a new function, which is called exponential, and it's going to have its own parent function as well. So an exponential function, we always start with a letter. We'll call it A. And then we have another letter. We're going to call that B. And we're going to raise it to the x. So an exponential function starts with a number. Then there's a number in parentheses. And it's raised to the x. Okay? So in this first example, the 3 is the number that's in the front. The number in the front is called the initial value. The initial value, that's kind of ugly, let me rewrite that, sorry guys. Value. The initial value of a graph of this type of function is also going to be its y-intercept. It's very different. Usually the y-intercept is in the back. In this function, the y-intercept, or the initial value, is in the front. Then we have a number inside. That's called my multiplier. Okay? And then it's always raised to the x, which is my my x is my independent number. So we're going to start by graphing this one here. So to connect it to what we did a minute ago, the number in the front is my starting number. In the situation that we dealt with a minute ago, we started with a penny, so 0.01 was my starting number. So in this example, my starting number is the number 3. So I'm going to put that on my table that we're going to start at 3. Okay, so then we're going to continue to increase these numbers here. So now the number inside is called my multiplier. So in the last situation, we said we had a penny, and it's doubling every time. So in this one, we start with a number 3, and this number 3 is going to double every time. Exponential functions means there's a multiplier. It's kind of ugly, it's okay. So if I start at 3, and I double it, 3 times 2 is 6. I double that, that's 12. I double that, that's 24. I double that, that's 48. Okay, so now I'm going to graph it. I'm going to start at 0, 3. That's my y-intercept, or my initial value. The next number I move over, the independent number, is 1. But when I doubled my y value, now we're at 6. 1, 2, 3, 4, 5, 6. That's ugly. Okay, so then I doubled it again, and now my y value is up 12, which is like up here. So what happens is this gets really big really, really fast. Now the way that these graphs work is you're going to connect your dots, but it's also going to continue down this way forever. So if I plug this into Desmos, y equals 3, open parentheses 2 raised to the x, it would look like this red graph that I have on the screen. Okay, so an exponential function gets bigger and bigger. If you had plugged -1, so say that you wanted to know when x is -1, you would do 3 times 2 raised to the -1. 2 to the -1 is 1/2. 1/2 times 3 is 1.5. So when it's -1, it's approximately right there. Okay, so you could put negatives on here if you wanted to. Oops. Let's just get rid of you. There we go. Okay, so that's what this graph looks like. So let's refresh just a minute. The number in the front of this graph is called the initial value. So the 3 is where we started. So we're going to start at the number 0, 3. Then the number in parentheses is called the multiplier. So that means that my y values will multiply times 2 for each one of these situations. Once you complete the table, my x's are whatever number you want. So we're going to start at 0, 1, 2, 3, and 4 for all of these graphs. And you're going to use your multiplier to figure out your y values. So now we have some really important information that we need to fill out about this graph. Can I make it smaller? Maybe. Okay, so what we have now is the word asymptote. So asymptote was on your practice star test, and many of you guys were like, what in the world is that? So the word asymptote in Algebra 1, there's a y in it, so I'm going to write y equals. In this course, the asymptote is always going to be this line right here. What an asymptote is, it's a wall that my graph cannot pass. So that's what it means to be an asymptote. In this one here, my asymptote is sitting at this number. See how it's not passing? My red line's not going below this line. So there's no numbers that are going to live below there. In this graph, my asymptote, the line that it doesn't cross, is 0. So let's go backwards. So I'm just going to write this so it looks a little bit better. So it says, what is an asymptote? An asymptote is like a wall that the line cannot cross. Okay, where is the asymptote? So the asymptote has a y in it, so it's y equals. And the line that this is not crossing is the number 0. for this whole worksheet, the asymptote is going to sit at 0. On your practice star test, the asymptote was at 0. So this means that my red line on my graph is never going to go below a 0. So now the y-intercept, we can get that in two places. We can look at my graph, and I can see it crosses the y-axis at the number 3. You could have looked at the table, and it has the ordered pair, 0, 3 on that table. Or you could have looked at the original question. The y-intercept is the initial value, which is the number in the front. Very easy. Next, domain and range. So domain of this type of graph is the x's. So domain's always x. So in this type of graph, there's an arrow on the left, so it's going to continue moving forever to the left. And there's an arrow on the right, so it's going to continue going forever to the right. So my domain is all real numbers. Or you could put the fancy R, all real numbers. So the domain of this graph is it goes forever to the left and it goes forever to the right. My range is my y's. What you'll notice is there's no y, there's no numbers down there. My red graph does not live on the bottom part of the y-axis. So if my range is my y, all of the numbers are above 0. So the y values all live above the number 0. So that's the range of this graph. Not too bad. Okay, so here's our first page. We're going to try this a couple times. Then you're going to try some on your own. Then we'll have one final page, and that's everything for today. All right, I'm going to do numbers. I'm going to start you off with number 1, then you can finish number 1. So in number 1, what we know is the word y-intercept. The y-intercept of this graph is the initial value. The initial value is where we start at 0, 2. On my table, I'm going to put 0, 2. I'll let my x's keep going. My asymptote is always y equals. My domain, you'll see it in a second, and range, you'll see in a second. So in this one here, I start with a number 2, because that's my initial value. In this one, I have a multiplier, if that's a number 3. So that means that each y value, we're going to multiply them times 3. They're going to get really big really fast. 2 times 3 is the number 6. 6 times 3 is 18. 18 times 3, 24, 54, 54 times 3, 162. Okay, so that's my table. So I started with my initial value, which was the number in the front, which was 0, 2. And then my multiplier is 3, so I multiply my y values times 3 each time. Your x's are always just 0, 1, 2, 3, 4. So when you're ready, go ahead and sketch this graph. Hint, it's going to look something like this. So you can sketch the ordered pairs that you can sketch. So domain, what I notice about this graph is it goes forever to the left and forever to the right. The domain is called all real numbers, because it goes forever to the left, and this arrow is going to keep going forever towards the right. The range is the y. My y values live above the asymptote. My asymptote, meaning this line's never going to drop below a 0. If this confuses you, you can just go into Desmos, type in that equation, and see if it works. You can also just go to Desmos and click the little spiky circle, the table, and you can match your table. Very easy. Okay, I'm going to do one more with you. So in this one here, nice and easy. Okay, my y-intercept is the initial value. The initial value is the number in the front. The number in the front is a 5. So that's my initial, my starting number on my table. We're going to put 0, 5. My multiplier for this one is a fraction, 1/2. So what that means is I'm going to take my y numbers from my table. I'm going to multiply each of them. I'm going to cut them in half. thing times 1/2. So half of 5 is the number 2.5. Half of 2.5 is the number 1.25. Half of 1.25 is the number 0.75, I think. And half of 0.75, so you can go to a calculator and double check that. So these numbers are getting smaller because our multiplier for this one is a fraction. So they're cutting in half. So on a graph, we start at 0, 5. 1, 2, 3, 4, 5. 1 goes to 2.5. 2 goes to 1.25. It's real ugly. And then that would keep getting cut in half for the next one, and in half for the next one. So what that means is when you connect your dots, it's going to look like this. So this graph, because my multiplier is a fraction, this one's going downward. It still has an asymptote at 0. It's never going to go below 0. So my asymptote is the number y equals 0. My domain of this type of graph is always going to be all real numbers. And my range is that all of these y values live above the number 0. Not too bad. In this final one here, in number 3, there's an invisible initial value. If there's no number in front, there's an invisible 1 there. So my y-intercept, the number in front, is the number 0, 1. So if there's no number there, put a 1. The multiplier is always the one that's in the parentheses. So what I'm going to do is I'm going to multiply times 2 at each level. Because the multiplier is 2. My x's will stay the same. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So now I can graph it. 0, 1. 1, 2. 2, 4. 3, 8. And 16. So it's going to look like this. Never crosses below 0. So when you're ready, go ahead and answer. Where is the asymptote? What is the domain? And what is the range for this question here? All right, so we now move into the last part for today. So this final piece that we have here is the same thing. It just adds one word to it. So what we just learned is that the number in front is called the initial or the starting value. So sometimes they call it the initial value. Sometimes they call it the starting value. It's the same thing. So that's the number in front. That's what we just messed with. That was A. The number that comes next is B. We just called that the multiplier. And then the number on the top is always the letter X. When we do real world problems next week, we'll put numbers up there. But for now, it's always going to be an X. All right, so what we know is that if this number right here, the multiplier, if it's bigger than 1, let's look at our example. So in this one here, my multiplier was a number that was bigger than 1. So therefore, this graph went upward. So if your multiplier is bigger than 1, my graph is going to go up. If it goes up, it's called a growth. I should say then. If my B number, my multiplier number, if it's bigger than 1, then this graph is a growth. If this number, my multiplier, is between 0 and 1, which means if it is a fraction, so in this example, it was a fraction, my multiplier was 1/2, this graph is dropping downward, so that is called a decay. So this is called exponential growth and decay. So exponential growth means we start with a number and it gets bigger and bigger and bigger and bigger. For example, when COVID started last year, some scientists said that it was exponential growth, where the number of people that were infected were doubling and doubling and doubling, got more and more and more people with positive cases. Another example of growth is, say that you buy a house and that house ends up being worth a lot of money. The more time that passes, the value of your house gets bigger and bigger and bigger. That's called a growth. Now, a sad thing is decay. So a prime example of decay, we'll talk a lot more about this next week. Say that you get a car for $10,000. The minute you start driving that car, it's worth less and less and less. Its value is cutting in half and in half and in half. So this would be a decay. So again, we'll talk more about the real life part of that later. So what we need to know is if the B number, the number that's in front of the X, if it's bigger than 1, it's called a growth. If it's a fraction between 0 and 1, it's called a decay. Very easy. So let's look at these examples. This first one is dropping downward, so that's called a decay. The next one is moving upwards, so that's called a growth. This last one, what do you think? Drops downward, so it's called a decay. Not too bad. Okay, this is the last piece for today, and then you can move into your exit ticket. So in this first example, is it a growth or a decay? Well, let's see. The number in parentheses, is it bigger than 1? Yes, it's bigger than 1. So therefore, this is a growth. What is the initial or the starting value? The value it starts at is the number 3. What is the growth or decay factor? The number at which it's growing is 1.8. So I want you to try the same thing with numbers 2, 3, and 4. This is 1.01 is my multiplier. Because it's bigger than 1, it's called a growth. What is the initial value? What is the number that it's growing by? Number 3, 0.8. I'll do this one with you. So my multiplier is 0.8. Is 0.8 bigger than 1? No. 0.8 is a decimal that's between 0 and 1. So that means it would be dropping. So if you multiply something times 0.8, it makes it smaller and smaller and smaller. So this is a decay. Again, my initial value is the number in front. That number in front is the number 9. The number at which this is decaying by is a 0.8. Very easy. Okay, so go ahead and finish up numbers 2 and 4. Once you complete this, you can go to your exit ticket and try those few questions. Tomorrow, we're going to practice graphing exponentials and labeling key attributes. Nice, easy week.